Today, we seek something more. We seek the edge. We feel its distant whisper, a subtle yet persistent call from the unfathomable depths, beckoning us to peer beyond the known, to stretch the very limits of our comprehension. What is this mysterious edge of space? This cosmic boundary that has haunted our collective imagination for eons? What truly awaits us there, at what we so often refer to as the final frontier, that ultimate threshold of perception and understanding? And what, if anything, can possibly lie beyond that ultimate boundary, that conceptual limit, where our current models of reality may cease to hold sway? This is not merely a question relegated to the austere halls of astronomy, nor is it a dry academic inquiry confined to the intricate equations of theoretical physics. No, this is a question that has been murmuring to us, gently yet profoundly, since the very dawn of our consciousness, an ancient, fundamental query echoing through the corridors of time. It is a question about the inherent nature of our container, this vast, silent expanse that cradles our existence. It is a question about our home, this transient sphere we inhabit, nestled within a cosmic architecture far grander than we can ever fully grasp. It is a question that probes the very essence of our reality, shaping the contours of our understanding and the boundaries of our imagination. Indeed, it is a question whose profound and shifting answers have served to define us, to sculpt our understanding of ourselves and our place in the universe, century after century, civilization after civilization, each one constructing its own unique vision of the cosmos. For in daring to reach for what we perceive as the very edge of the universe, in attempting to chart its remotest shores, we inevitably and perhaps paradoxically often find ourselves confronting, and perhaps even glimpsing, the very edge of ourselves, the limits of our own knowledge, the boundaries of our own being. Cosmology, that grand and awe-inspiring science of the universe, it really stands apart in its magnificent ambition. It's not just about the meticulous charting of distant stars, or the painstaking mapping of swirling galaxies, or the precise measurement of cosmic distances. No, its true essence lies in a far more encompassing aspiration. It is, perhaps, the singular human endeavor that strives not to break things apart, not to, dissect reality into smaller and smaller, more manageable fragments, but rather, with a profound sense of reverence and intellectual humility, to put them back together again, to weave a coherent tapestry from the disparate threads of knowledge we painstakingly gather. So, while other sciences, with their focused lenses, are peering intently into microscopes, diligently dividing reality into ever smaller pieces, dissecting the intricate dance of life into its constituent cells, dissolving the solid world into a shimmering mist of particles and fundamental forces, the cosmologist assumes a different vantage point. The cosmologist looks not only through the powerful, light-gathering lens of the telescope, gazing out into the boundless expanse, but also, and perhaps more importantly, through the subtle, discerning lens of the mind's eye. Well, this is a quest for synthesis, an attempt to assemble the myriad fragments of knowledge, the insights from physics, chemistry, mathematics, and even philosophy, into what a poet once called a mighty frame. Like a single, coherent and all-encompassing picture of everything, a unified vision of existence itself. It's a relentless, yet profoundly peaceful, search for the underlying architecture of existence, a scientific art form that dares to paint the largest canvas imaginable, encompassing all of space and all of time within its sweeping brushstrokes. And in this magnificent, all-encompassing search, we find ourselves compelled to look not just outwards, to the staggering grandeur of receding nebulae and the ever-expanding horizons of cosmic light, but also, and with equal intensity, inwards. We are drawn to examine the very structure of our own thoughts, the intricate machinery of human consciousness, and to recognize the ancient, vestigial paradigms, the inherited ways of seeing and believing, that still ghost through the shimmering corridors of our modern minds, subtly influencing our perceptions. Because what we believe about the cosmos, whether we are consciously aware of it or not, shapes absolutely everything. I mean, it's the silent, often invisible, yet profoundly powerful force that, like an unseen current, directs the destiny of societies, steering them towards their rise or their eventual decline. It subtly influences the revolutions we ignite, the wars we tragically fight, the fortunes we diligently seek to gain, the deepest love we are capable of feeling, and the very future we strive with all our might to build. Every momentous act, every significant decision, every profound human emotion is colored, implicitly or explicitly, by a cosmic belief, a deep-seated, often unconscious map of reality that we carry within us. And on that map, inevitably, somewhere near its fraying, unexplored borders, there is always a whispered question, a lingering uncertainty, a quiet curiosity about the ultimate edge. You know, throughout the long, winding tapestry of our history, in every age and in every distinct society that has risen and flourished upon this planet, we have harbored a profound and often comforting conviction that we have finally, at long last, irrevocably discovered the true and definitive nature of the universe. Each epoch in its serene certainty looks back upon the previous one with a kind of gentle pity, maybe even a benevolent amusement, for its charming but, in retrospect, obviously innocent ignorance. The intricate celestial mechanics of Ptolemy or the fervent angelic choirs of the medieval cosmos seem, to our modern eyes, to possess a beautiful naivete. And yet, each epoch, in its turn, will undoubtedly be viewed with precisely the same condescending fondness, the same gentle, knowing smile, by its own distant descendants, who will, in their future wisdom, perceive our current understanding as equally simplistic, equally charmingly misguided. In truth, what we have only ever managed to devise is a magnificent mask, an exquisitely crafted model woven from the finest, most intricate threads of our current knowledge, our most advanced theories, and our most precise observations. Well, we then meticulously fit this mask onto the enigmatic, ever-shifting face of an unknown and perhaps, at its deepest core, even unknowable reality. The very word universe, when capitalized, it stands as too grandiose, too final, too definitive in its pronouncement. It subtly conveys a false and comforting impression that we have indeed solved the ultimate riddle, that we have pierced the veil and laid bare the cosmic truth. Let's be more humble, then, in our cosmic contemplation. Let's speak not of the singular universe, as if it were a conquered territory, a neatly contained domain whose boundaries we have fully explored, and whose secrets we have entirely unearthed. Instead, let's talk about universes, the many diverse models we ceaselessly construct, generation after generation, in our persistent endeavor to make sense of our complex, often bewildering experience. We call our current, prevailing model, the one born from the triumphant march of modern science and its groundbreaking discoveries, the physical universe. It is a thing of dynamic curvature, a cosmic fabric woven from the subtle geometry of spacetime. It's a realm punctuated by the bewildering dance of quantum foam, a seething, effervescent uncertainty at the very smallest scales, and permeated by the mysterious, accelerating push of dark energy, an enigmatic force that continues to confound our deepest understanding. But let's never forget, in our moments of intellectual pride, that it is still just one luminous portrait in a long and ever-expanding gallery of cosmic pictures, each one a self-contained universe unto itself, a unique window into a segment of perceived reality. And so, we stand now, in this luminous moment of intellectual achievement, proud of our accumulated knowledge, confident in the groundbreaking theories of relativity and the profound mysteries of quantum mechanics that underpin our understanding. We look back with a certain degree of detached admiration, perhaps, at the elegant celestial spheres and the comforting earthly centers of our ancestors, cosmic visions. Yet, do we sometimes fail to truly see, to grasp the profound irony that our own descendants, centuries into the distant future, will undoubtedly look back upon our Einsteinian universe, upon our now familiar concepts of Big Bangs and enigmatic black holes, and see in them a quaint simplicity, a beautiful yet ultimately limited attempt to grasp the infinite. Cosmology, in its deepest essence, is the study of these universes, these grand evolving masks, how they originate in the depths of the human mind, how they subtly evolve and adapt with our expanding understanding and the accumulation of new evidence, and how they eventually, inevitably, fade, gently receding into the mists of history, only to be replaced by a new vision, a new and perhaps even more profound attempt to glimpse the true, unadorned face of the cosmic mystery that our ancient, relentless quest for the edge began long, long ago, far beyond the reach of written history, in the dim primordial mists of human origins. Hundreds of thousands of years ago, in what we might, with a certain poetic license, call an age of magic, our ancestors perceived the world not as an inert collection of objects, but as a vibrant, living entity, teeming with intentionality, animated by an omnipresent host of ambient spirits. Every rustle of leaves in the ancient forest, every gentle ripple on the surface of a pristine lake, every sudden gust of wind whispering through the tall grasses, all were interpreted as the direct action of a conscious being, a spirit with impulses and passions not unlike our own, capable of both benevolence and capricious wrath. It was a profoundly anthropomorphic world, a cosmos in which human thought and feeling, our joys and our fears, our desires and our anxieties, were not merely reflected but actively projected onto the very fabric of nature itself, blurring the lines between inner and outer realities. In such a world, there was no edge, in the sense that we, with our modern scientific paradigms, understand it. There was no distant spatial boundary to be reached, because the world was experienced as a living, breathing whole, an interconnected web of life and spirit, and the spirits themselves were everywhere, permeating every stone, every tree, every cloud. The true boundary, then, was not one of physical space, not a distant horizon, but rather a more ethereal, permeable one, a boundary of spirit and power, a threshold between the human and the divine, between the seen and the unseen realms of influence. Then, maybe tens of thousands of years ago, as human societies grew more complex, as agriculture began to root us to the land, and as our understanding of the world deepened through observation and ritual, a new and more structured vision of the cosmos slowly emerged from the collective human psyche, the age of myths. The myriad individual spirits, once so pervasive and intimately connected to every natural phenomenon, began to amalgamate, to coalesce, as they subtly retreated into distant, often inaccessible heavens, transforming and elevating themselves to become powerful, archetypal gods and goddesses. Their capricious will, their divine dramas, their loves, their jealousies, their epic battles, played out on a vast, celestial stage, now serve to explain the rhythmic turning of the seasons, the predictable rising of the sun from the eastern horizon, the unpredictable storms that lashed the land, the inescapable fate of mortals, and the very fundamental structure of their ordered world. In the ancient Sumerian imagination, a cosmos cradled in the Fertile Crescent, the entire universe was believed to have been born from a primeval, chaotic watery abyss, a tumultuous struggle between powerful, primordial beings, a cosmic creation story that mirrored the ever-present struggle against the unpredictable floods of the Tigris and Euphrates. To the ancient Egyptians, living along the life-giving Nile, the vast azure sky itself was embodied as the graceful goddess Nut, her body arched protectively over the prone, fertile form of the earth god Geb, their eternal separation, the very space between heaven and earth, maintained by the constant, vital presence of the air god Shu. The universe, in their profound spiritual narrative, was not merely a mechanical system, but an intimate, interconnected family drama, a cosmic tapestry woven from divine relationships and archetypal interactions. And for countless other cultures, stretching across continents and millennia, from the icy sagas of the Norse to the intricate cosmic calendars of the Mayan civilization, the cosmos was a structured, hierarchical place, typically with defined realms, a celestial heaven above, an enigmatic underworld below, and the vibrant world of humanity, our familiar home, comfortably nestled in between, serving as the crucial intermediary space. In both the magical and the mythical universes, despite their vast differences in scale and complexity, humanity remained of paramount, central importance. The cosmos, in these ancient narratives, was invariably built for us, designed for our habitation, our dramas, our struggles. We stood, without question, at its very center, the unwavering focus of divine attention, the protagonists in a grand cosmic play. This profoundly comforting, anthropocentric vision of a human-centered cosmos was given its most sophisticated, enduring, and logically rigorous form by the ancient Greeks, a civilization that, with its burgeoning philosophical schools and its revolutionary embrace of geometry, began the gradual, profound process of replacing untamed myth with the disciplined elegance of reason and the precise certainty of mathematical logic. From their brilliant minds, particularly those of Plato and Aristotle, came the elegant, harmonious, and remarkably enduring geocentric universe, a system that would dominate Western thought for nearly 2 millennia. Here, for the first time, was an edge defined not by a whimsical story or the arbitrary will of gods, but by a precise, coherent system of physics and rigorous logic. The spherical Earth, our familiar terrestrial home, a realm perceived as one of constant change, inevitable corruption, and ultimate decay, rested, by logical necessity, at the perfect, undisputed heart of all things. It was a place characterized by imperfect, linear motion, the simple, gravity-driven movements of up and down, of objects falling to their natural place. Well, above it, in a realm of celestial perfection and absolute immutability, the celestial bodies, the moon, the sun, the planets, and the fixed stars, were believed to be eternally fixed to a series of concentric, translucent, crystalline spheres. These spheres, driven by unseen movers, spun in eternally perfect, unchanging circles, their motion considered the epitome of divine harmony and mathematical elegance. This was the celestial realm, a place utterly distinct from our earthly domain, made not of the 4 common earthly elements, earth, water, air, and fire, but of a mysterious, pure, and incorruptible 5th element, the ethereal quintessence, a substance of perfect, unchanging nature. And at the outermost boundary of it all, encompassing every other sphere, was the magnificent sphere of the fixed stars, a cosmic shell studded with countless, unchanging points of light, serving as the final, flaming rampart of the world, a definitive cosmic wall beyond which, by definition, there was no space, no time, no being, no existence whatsoever. This remarkably stable and psychologically satisfying model, further elaborated with breathtaking geometric ingenuity and observational precision by the astronomer Claudius Ptolemy in the 2nd century CE, became the undeniable cornerstone of the medieval world, serving as the ultimate intellectual and spiritual framework for over 1,000 years. For generations, this profound and coherent vision gave immense meaning, deep purpose, and an unshakable sense of order to human life. It was a cosmos that was simultaneously science, philosophy, and religion, a finely tuned, finite, and beautifully well-organized universe where everyone and everything knew their precise, ordained place in the grand scheme of things. A meticulously structured great chain of beings stretching seamlessly from the lowest, inert stone at the bottom of creation to the highest, most resplendent seraphim, those fiery, pure spirits residing in the glorious empyrean heaven that lay just beyond the sphere of the fixed stars. It was perhaps the most psychologically satisfying cosmology ever devised. A universe with a comforting, undeniable center for us, and a clearly defined, absolute edge that physically separated our earthly home from the divine, from the realm of ultimate truth and spiritual perfection. But our long, arduous journey to the modern scientific understanding of the edge of space, and indeed of space itself, required us to perform an act of profound intellectual courage, and relinquish this comfortable center, to shatter its solid crystalline walls and embrace a new, disorienting freedom. The Copernican revolution, a transformative process that did not unfold in a single moment but rather stretched and matured over 2 long and tumultuous centuries, began not just with the cautious, almost reluctant, astronomical repositioning by Nicolaus Copernicus, who dared to place the Sun, rather than the Earth, at the center of the planetary orbits. It began with a deeper, far more unsettling realization that rippled through the intellectual landscape. If the Earth moved, if it was indeed just another planet, orbiting a star, then why not the Sun? And if the Sun was not the eternal, fixed center of the entire cosmos, then where, truly, was the center? Was there even a center at all? This intellectual and spiritual revolution culminated, 2 centuries later, in the vast, infinite, and profoundly centerless Cartesian and Newtonian world systems, grand mechanistic conceptions of the universe that swept away the old order. Giordano Bruno, the fiery Italian monk, a passionate and visionary thinker, became a tragic martyr for this radical, boundless vision. He preached with fervent conviction of a universe of truly infinite extent, populated not merely by one sun and one world, but by numberless suns, each perhaps circled by countless other worlds, each one teeming with life, a Christianized echo of the ancient Epicurean dream of an infinite cosmos of atoms and the void. For Bruno, God's infinite majesty and boundless power were not diminished but infinitely glorified not in the creation of a single finite world, but in an unfathomable infinity of worlds, each a testament to divine creativity. For this daring, heretical vision, for his refusal to recant, he was tragically burned at the stake in Rome's Campo dei Fiori in 1600. Yet the idea, once unleashed into the human consciousness, proved to be far more powerful and pervasive than the flames that consumed his body. It could not be contained by fire or repression. The solid sphere of stars, that ultimate crystalline edge of the old cosmos, was conceptually shattered and dissolved into boundless space by the quiet, revolutionary insight of Thomas Digges in England. In 1576, He depicted the stars not as gems on a finite, encompassing sphere, but as a boundless, scattered ocean of luminous points, extending infinitely in all directions, a radical reimagining of cosmic space. He was grappling implicitly with a profound question posed 2 millennia earlier by the Epicurean poet of ancient Rome, Lucretius, in his philosophical poem De Rerum Natura, On the Nature of Things. Lucretius had famously imagined standing at the supposed edge of the universe and flinging a spear. If the spear stops, he argued, then there must be something beyond the edge to stop it, implying the edge was not an edge at all. And if it flies on endlessly, then the supposed edge was merely an illusion, a false boundary. In a universe that by its very definition has no outside, there can logically be no true physical boundary, no final wall. The question itself, simple as it may seem, is a subtle and brilliant trap because it reveals the inherent logical impossibility of a simple physical edge. Whatever bounds the universe, whatever defines its limits, must, by that very definition, itself be part of the universe. The edge, if it exists, must be within, not without. This monumental intellectual shift, this radical reimagining of cosmic space, was nothing short of cataclysmic in its immediate and profound impact. It wasn't just a benign change in astronomical diagrams or a technical update to celestial charts. It was a profound spiritual dislocation, a deep-seated philosophical vertigo induced by the sudden, terrifying removal of all familiar cosmic walls and comforting floors. The cozy, finite, beautifully ordered room of the medieval cosmos had been violently exploded, conceptually, into an infinite, often terrifyingly featureless expanse, a cold, dark void that seemed to stretch forever. And now, just as humanity was beginning to adjust, however painfully, to this new boundless cosmic freedom, another seismic shift occurred. Then came Darwin, and the dislocation, already profound, became an even more acute expulsion. No longer did humanity occupy the central, privileged position in the physical world, orbiting a fixed Earth. Now humanity was also cast out from the center of the living world as well, revealed by the relentless logic of natural selection to be not a special divinely created being, occupying a unique, exalted status halfway between angel and beast, but rather an evolved animal, intricately kin to the apes, a part of the grand, interconnected tapestry of life, not separate from it. The great chain of being, that meticulously ordered hierarchy which had for so long anchored us as the crucial, privileged link between the earthly and the divine realms, was fundamentally broken, its links shattered by the hammer of scientific discovery. Science, in its triumphant march, with its emphasis on empirical observation and rational inquiry, put to flight the old gods and the ancient myths, dismantling their elaborate narratives. But in doing so, it inadvertently, or perhaps inevitably, cast humanity adrift in what felt, to many, like an alien, cold, and utterly meaningless cosmos, a vast, indifferent machine operating without purpose or design. The loss of a divine, purposeful center left many adrift, yearning for a sense of belonging in the cold, boundless immensity. Yet, amidst this perceived desolation, there is a profound, and, when you truly grasp it, deeply comforting irony woven into the very fabric of this story. While we may no longer occupy the literal physical cosmic center of the universe, while the universe itself is demonstrably not made in our image, not crafted to serve our specific needs, it is, in a most profound and inescapable sense, we who are its measure. Every universe we have ever conceived, every intricate model from the animistic, magical world of our earliest ancestors to the meticulously structured geocentric cosmos of the medieval period, to the bewildering complexity of our modern scientific understanding, is inescapably anthropometric. It is a grand mental edifice, a towering, intricate picture of reality constructed entirely within the sophisticated confines of the human mind-brain. It's built from the raw, unfiltered data of our senses, the light our eyes perceive, the sounds our ears detect, the tactile sensations that define our immediate world, and meticulously shaped by the abstract, intricate logic of our thoughts, the powerful machinery of reason. Our intricate theories about space-time, about quantum mechanics, about dark energy and the expansion of the universe reside not inherently in the distant stars themselves, not etched into the fabric of space, but rather in the delicate, flickering neural pathways of our own complex brains. Our modern physical universe, with its biochemically complex human minds pondering over its mysteries, is just as much a human creation, a product of our consciousness and our intellectual endeavor, as the comforting geocentric cosmos of our ancestors. And like all universes before it, it too will one day subtly fade, gently receding into the mists of intellectual history, only to be replaced by a new conception, a new and perhaps even more profound understanding, born from minds yet to come, minds shaped by new knowledge, new questions, and new ways of perceiving reality. Well, so, the true capital U universe itself, the ultimate unmediated reality, is not, of course, human-made. It exists independently of our perception. But our grasp of it, our intricate model, our particular universe, is entirely our own construct. All we know for certain, with an almost aching clarity, is that this true universe contains us, the dreamers of universes, the architects of cosmic models. We are, in a very real, profound, and perhaps even mystical sense, the universe itself, attempting to understand itself, to awaken to its own magnificent complexity. This intimate, unbreakable bond, this subtle yet powerful connection between cosmology, our grand stories about the universe, and society, our collective human experience, is the unseen current, the silent, invisible force that so often directs the deep river of history, steering its course through the ages. Where there is a society, a collection of human beings living together, there inevitably arises a universe, a shared understanding of the cosmic order. And where there is a universe, a grand cosmic narrative, there is, by definition, a society of thinking beings who live within it, shaped by its assumptions, guided by its principles. The ways of the gods, the perceived cosmic order, subtly but profoundly become the ways of people, influencing their ethics, their laws, their daily lives. If the gods are perceived as cruel, capricious, and vengeful, then cruel acts and social injustices are often sanctioned, even encouraged. Conversely, if the gods are benevolent and peaceful, then societies tend to foster peace, compassion, and cooperation. Consider for a moment an idea as seemingly abstract, yet as monumentally powerful as the principle of plenitude. This concept, born from the deeply anthropocentric belief that an all-good, all-powerful creator made a world of unlimited bounty specifically and exclusively for mankind, designed to serve our every need and desire, rooted deeply in ancient Greek thought and amplified profoundly after the Renaissance, had truly astonishing and far-reaching consequences. This single cosmological idea, this deep-seated belief in infinite abundance, fueled the entire age of exploration, inspiring voyages across uncharted oceans and the discovery of new lands. It subtly yet powerfully justified endless colonial expansion, viewing newly discovered territories as endlessly exploitable resources for human benefit. And, perhaps most significantly, it laid the philosophical foundations for both the relentless drive of free enterprise capitalism, with its emphasis on infinite growth and consumption, and, paradoxically, its revolutionary counterpart, communism, which envisioned a society of total material abundance. The searing political question that continues to echo through our modern world, why should inequality of wealth exist in a world of unlimited abundance, is a direct, undeniable consequence of this ancient cosmic myth, this deep-seated belief in endless plenty. And it is, as we now painfully understand, fundamentally a myth. We do not, despite our deepest desires and our inherited beliefs, live in a world of unlimited resources. Today, in this precarious 21st century, we find ourselves facing an age of escalating crises. The undeniable specter of runaway population growth stretching our planet's limits, the rapid, often irreversible depletion of vital natural resources, the pervasive threat of environmental degradation, and the terrifying reality of atmospheric pollution fundamentally altering our planetary climate. We are, in a very real sense, haunted by the lingering ghosts of these obsolete universes, driven by cosmic beliefs and assumptions about infinite resources that, ironically, now threaten our very survival as a species. The true revolution we need, the one that will determine our future, is not merely one of technology, because technology is simply a powerful tool, morally neutral, capable of both creation and destruction. No. The true revolution, the one that must begin within each of us, is one of cosmology, a fundamental, profound shift in the deep and silent stories we tell ourselves about our inherent place in the vast, interconnected cosmos, about the true nature of our home, this fragile planet, and its genuine and demonstrably finite nature. The modern scientific journey, the one that has led us to our current astonishing understanding of the universe, truly began with a new and radically different kind of questioning, a shift in intellectual inquiry. As science, in its earliest nascent form, awakened in the bustling city-states of ancient Greece, particularly among the pre-Socratic philosophers, it was driven not merely by the why of the myths, the desire to understand the purpose or divine origin of phenomena. Instead, it was driven by the far more pragmatic and revolutionary how of the world, a rigorous pursuit of the underlying mechanisms and natural processes that governed reality. The Ionian philosopher-scientists, living along the coast of Asia Minor, were the trailblazers of this new way of thinking. They dared to imagine the cosmos not as the arbitrary result of divine caprice or the whimsical actions of gods, but as a dynamic interplay of fundamental, observable elements. Thales, perhaps the first philosopher, boldly proposed that water was the fundamental substance of all things. Anaximenes, his successor, posited air as the primary element, constantly changing, capable of rarefaction and condensation. Heraclitus, with his profound insights into change, declared fire to be the fundamental, ever-transforming principle. Or perhaps, as the radical atomists Leucippus and Democritus so astonishingly suggested, the universe consisted only of an infinite number of indivisible, indestructible particles, atoms, moving through an infinite, empty void, their random collisions giving rise to all observable phenomena. This was a vision of astonishing modernity, a truly prescient glimpse of later scientific thought. These thinkers fundamentally rejected supernatural explanations in favor of natural ones, seeking inherent order and causality within the physical world itself. Pythagoras, with his mystical and mathematical bent, saw a different kind of underpinning to reality, a universe that was a profound manifestation of mathematical harmony, the cosmos governed not by arbitrary elements, but by immutable numerical relationships and elegant geometric forms. He believed the heavens sang a silent, inaudible music, the music of the spheres, a symphony of mathematical ratios. In this vibrant, intellectually fertile ferment of ancient Greek thought, we can discern the primal, enduring tension that continues to define our modern physics. The dynamic, ever-changing, flux-filled world of Heraclitus, where you cannot step into the same river twice, a universe of ceaseless becoming, perpetually in motion. And, juxtaposed against it, the static, timeless, eternal, block universe of Parmenides, where all change is ultimately an illusion. A universe of eternal being, a fixed and unchanging reality. These early, intrepid thinkers were, without fully realizing it, sketching the very fundamental foundations, the abstract intellectual blueprints, upon which our grandest, most intricate theories of modern physics would one day be built, their insights echoing across millennia. Out of this explosive intellectual ferment of Greek thought, a period of unprecedented philosophical and scientific creativity, three great and enduring cosmic systems ultimately emerged, distinct philosophical frameworks that would profoundly shape Western civilization for 2 full millennia, each offering a fundamentally different, yet equally compelling answer to the persistent question of the cosmic edge, the ultimate boundary of existence. First was Aristotelianism, the finite, geocentric universe that would reign supreme for so long. This was a vision of absolute order and strict hierarchy, a perfectly organized cosmos bounded by the magnificent celestial sphere of fixed stars, beyond which nothing existed. This was the walled garden, a concept that provided immense psychological comfort, a finite, secure, and understandable dwelling for humanity. Second was Epicureanism, the radical universe of the atomists, which, in its bold conceptualization, fundamentally shattered those comforting walls. Here was an infinite, eternal void and boundless emptiness, populated by numberless, changeless, indivisible atoms, swirling and colliding in endless permutations. These atoms, through an infinity of chance collisions and aggregations, formed countless worlds, countless suns, all subject to the impersonal, uncaring laws of nature, without the intervention or even the concern of the gods, who, if they existed, dwelled in distant, ethereal realms, utterly indifferent to human affairs. This was a universe of immense freedom, but also of immense indifference. And third was Stoicism, a remarkably popular and influential philosophy throughout the Roman Empire, which offered a compelling and psychologically appealing compromise between the finite and the infinite. The Stoic universe was a finite cosmos of stars, much like Aristotle's, a perfectly ordered, living organism, governed by a divine reason. But it was emphatically not the whole of existence. It was conceived as a single, living, organic island of matter, intricately connected and pulsating with divine purpose, yet afloat in an infinite, empty, mysterious void, a vast expanse beyond its own boundaries. This vision stressed a divine spirit, a universal reason, an all-pervasive logos that permeated and governed a world of fate and immutable predestination, where virtue lay in accepting one's place in the cosmic order. These three powerful systems, the finite and bounded cosmos, the infinite and full cosmos, and the finite island in an infinite void, became the archetypes, the fundamental templates, for nearly every cosmological model to follow. Their silent, enduring debate echoing even in the most heated conflicts of 20th century astronomy, subtly influencing our perception of the universe to this very day. For a remarkable span of 700 years, this vibrant and profoundly influential Greek scientific and philosophical project flourished, reaching its zenith in the Hellenistic period, nurturing brilliant minds and producing enduring insights. Then, as the classical world slowly faded into history, its cultural treasures, its intellectual fire, its vast libraries of knowledge, did not vanish, but instead migrated eastward, carefully preserved and transmitted across continents. While much of Europe descended into what are often somewhat misleadingly called the Dark Ages, a period of reduced intellectual activity and fragmentation, the sacred flame of knowledge, of systematic inquiry and philosophical contemplation, was meticulously preserved and vigorously nurtured in the great, burgeoning cities of the rapidly expanding Islamic Empire, in the vibrant intellectual hubs of Damascus, the magnificent House of Wisdom in Baghdad, and the dazzling multicultural intellectual. Here, Greek, Egyptian, Persian, and Indian texts, spanning disciplines from mathematics to medicine, from astronomy to philosophy, were painstakingly translated into Arabic, meticulously studied, synthesized, and expanded upon with brilliant new commentaries, original research, and groundbreaking work in algebra, optics, and celestial mechanics. The new learning, rich and vital, infused with fresh perspectives and innovative methodologies, eventually flowed back into a reawakening Europe, acting as a powerful catalyst for the Renaissance and the eventual scientific revolution. The great medieval universities, intellectual powerhouses like Bologna, Paris, and Oxford, were founded and expanded, and scholars within their walls began the monumental task of piecing together a new, comprehensive vision of the cosmos, incorporating the newly available wisdom. The pinnacle of this grand synthesis was magnificently achieved by Thomas Aquinas, the towering Dominican theologian and philosopher in the 13th century. He masterfully wove the newly rediscovered rational framework of Aristotle's universe, with its precise logic and ordered hierarchy, with the rich tapestry of Christian doctrine, creating a seamless and profoundly resonant intellectual edifice. The result was the glorious medieval universe, a grand, exquisite unification of the spiritual and the physical, a cosmos that was finite, secure, and utterly drenched in divine purpose, a comforting and meaningful home for humanity. But, subtly, almost imperceptibly, the seeds of its own eventual destruction were already present, planted deep within its very foundations. The all-encompassing power of an omnipotent, infinite God, a central tenet of Christian theology, could not, logically, be constrained by Aristotle's neat, tidy, and ultimately finite physics. This profound theological tension, a simmering conflict between the limits of human reason and the boundless nature of the divine, reached a dramatic breaking point in 1277, when Étienne Tempier, the formidable Bishop of Paris, issued a series of condemnations, 87 propositions that were declared heretical. Crucially, he declared it heresy to suggest that God, in his infinite power, could not create other worlds, or could not move the earth if he so willed it. This explosive idea, this theological imperative of an unlimited, omnipresent God, burst the carefully constructed bounds of the finite Aristotelian cosmos. God, being everywhere, could not logically be confined to a specific, limited place, like the empyrean heaven just beyond the stars. And so, the universe, driven by theological necessity, had to conceptually expand to accommodate him, to contain his infinite presence. Beyond the solid sphere of stars, scholars, emboldened by this decree, began to imagine an infinite, divine void, a boundless spiritual space. Unknowingly, perhaps, the medieval universe was slowly but irrevocably transforming into a grander, more spiritual version of the ancient Stoic model, a finite island of matter, our familiar cosmos, adrift in an infinite spiritual sea, a boundless divine presence. This was the profound and complex intellectual landscape of thought when Nicholas Copernicus, a quiet, Polish canon, dared to place the sun, not the earth, at the center of the planetary system. His revolution, however, audacious as it was still deeply rooted in the old ways, still driven by an ancient aesthetic. He sought to restore the ancient ideal of perfect circular motion, a Platonic ghost that still haunted astronomical thought. But to match the intricate, observed dance of the planets, his system, paradoxically, became just as complex, just as cumbersome as Ptolemy's, a tangled web of circles upon circles, of epicycles and deferents. He had boldly shifted the center, but he had not yet truly broken the ancient limiting frame. That final, decisive shattering of the old cosmic order, the intellectual liberation from the confines of the medieval universe, required minds willing to confront, head-on, the profound and disorienting vertigo of infinity. Thomas Digges in England, a Renaissance polymath, and Giordano Bruno in Italy, the passionate philosopher-monk, were among the first to truly see the stars not as sparkling gems fixed to a solid celestial sphere, but scattered like luminous dust, suspended within an endless, unbounded void. The center is everywhere, the circumference nowhere, they proclaimed, echoing the mystical insights of Nicholas of Cusa, a 15th-century cardinal and philosopher who had conceptualized God as an infinite sphere whose center is everywhere and circumference nowhere, and that therefore the universe, being God's creation, must also reflect this infinitude. This was far more than a mere astronomical proposition. It was a profound philosophical declaration of cosmic democracy, a radical act of intellectual dethroning that stripped not only the Earth, but indeed any single point, from a privileged central status. The great Tycho Brahe, the most meticulous and accurate naked-eye observer of his age, with his unparalleled instruments and his dedicated, tireless life of observation on his island observatory of Uraniborg, vehemently resisted this terrifying new concept of an infinite universe. If the Earth truly orbited the Sun, he reasoned, performing a grand annual revolution, then we should be able to detect a tiny observable shift in the apparent positions of the nearest stars against the distant background over the course of a year, a phenomenon known as stellar parallax. Yet, despite his instruments' unprecedented precision, he could detect no such shift, no measurable parallax. Therefore, he concluded with compelling logic, either the Earth was indeed stationary at the center of the cosmos, or the stars were at such almost inconceivable distances that their true sizes, to appear as they did, would have to be monstrous, unimaginably vast, utterly dwarfing our own Sun. His clever, pragmatic compromise was a geo-heliocentric system where the planets orbited the Sun, which in turn, along with the entire celestial apparatus, orbited a stationary Earth. It was a brilliant, elegant attempt to reconcile the new observations with the old paradigm. But it ultimately fell to his brilliant, often troubled and fiercely persistent assistant, Johannes Kepler, a mystic obsessed with the grand cosmic harmonies underlying all existence, to truly decipher the enigmatic new heavens. Kepler was initially appalled, even horrified, by the idea of an infinite universe, a concept that seemed to defy the divine order and the geometric perfection he so passionately sought, like new heavens. Kepler was initially appalled, even horrified, by the idea of an infinite universe, a concept that seemed to defy the divine order and the geometric perfection he so passionately sought. This very cogitation carries with it, I don't know what secret hidden horror, he confessed in a letter, revealing his deep discomfort with such boundless immensity. Indeed, one finds oneself wandering in this immensity as in a labyrinth, and one finds no limit to the wanderings. He inherited Tycho's lifetime of priceless, meticulously recorded, precise observational data, a treasure trove of astronomical measurements, and for years he labored relentlessly, almost obsessively, to fit the perplexing, stubborn orbit of Mars into a perfectly sun-centered system of perfect circles, still clinging to the Platonic ideal. At last, in an act of profound intellectual courage, a truly revolutionary break with 20 centuries of ingrained thought, he abandoned the circle, that ghost of ancient perfection. He discovered his three great laws of planetary motion, which revealed that planetary orbits were not circular, but exquisitely elliptical, elegant ovals. He had at last discovered the true mathematical harmony of the spheres, and it was written not in the perfect symmetry of circles, but in the graceful, dynamic curves of ellipses, with the sun not at the exact center, but at one focus of each planetary orbit, subtly off-center. Finally, the revolution was armed with a powerful new instrument, both intellectual and literal. Galileo Galilei, the audacious Italian polymath, turned his newly fashioned modest telescope, a marvel of optical engineering for its time, toward the heavens, and what he saw through its lens systematically dismantled the old world, piece by painstaking piece, revealing a cosmos far richer and more dynamic than previously imagined. He saw rugged mountains and deep valleys on the moon, proving conclusively that the celestial realm was not a place of incorruptible, pristine perfection, but a world like our own, marked by change and imperfection. He saw dark, changing spots on the sun, further eroding the notion of celestial immutability. He saw 4 new stars, circling the planet Jupiter, the Jovian moons, proving conclusively that not everything in the heavens orbited the Earth. He saw that the hazy, ethereal band of the Milky Way, our own Via Lactea, resolved into a vast, uncountable multitude of individual stars, a stellar ocean of unimaginable depth. And he saw that the stars, even through his most powerful magnifications, remained as infinitesimally small points of light, their apparent size an optical illusion, thus demolishing Tycho's most powerful observational objection to a moving Earth. For his clear-sighted, forthright declaration that the Earth moves, supported by his telescopic observations and his elegant arguments, he was summoned by the formidable Inquisition and forced, in his old age, under the implicit threat of torture, to abjure his deeply held beliefs. The Earth remained, by ecclesiastical decree, stationary, but in the boundless world of ideas, its conceptual motion had been set irrevocably in motion, destined to sweep away the old order. The ancient celestial sphere, that final crystalline wall of the classical and medieval cosmos, had been utterly shattered, its fragments scattering across the intellectual landscape. From the conceptual rubble, 2 new and monumental systems arose in the vibrant intellectual ferment of the 17th century, each offering a universe that was mechanized and mathematized, a grand clockwork cosmos, governed not by arbitrary whim or divine will, but by unwavering, impersonal natural law, discernible through human reason. The first was the Cartesian world of René Descartes, the brilliant French philosopher and mathematician. It was an infinitely extended universe, a vast, boundless expanse, but it was emphatically not empty. Echoing the ancient dictum of Aristotle, Descartes declared that space could not exist without matter, to give it extension, to define its very being. A vacuum is repugnant to reason, he insisted, believing that nature abhorred a vacuum. The cosmos, in his grand vision, was a plenum, a single, continuous, infinitely divisible substance, a fluid-like medium filled with colossal, swirling vortices of matter, immense, cosmic whirlpools. Planets, in this model, were simply caught in these immense cosmic maelstroms, carried around their central stars by the flowing ether. In this clockwork universe, all forces acted by direct, physical contact. There was no mysterious, inexplicable action at a distance across empty space. But Descartes' most profound and enduring legacy, the one that continues to shape our thinking to this day, was his sharp, almost surgical division of reality into two distinct and fundamentally separate realms, that of body, res extensa, extended substance, and that of mind, res cogitans, thinking substance. The physical world, which included the intricate machinery of the human body and even the physical brain itself, was conceived as a complex machine, a piece of intricate clockwork, governed by mechanical laws. The mind, or soul, was something else entirely, an immaterial, unextended ghost haunting that machine. Wait, what? How, precisely, could this intangible ghost influence the gears and levers of the physical clockwork, the material brain? This perplexing question, the mind-body problem in its starkest, most challenging form, still vexes our deepest philosophies and continues to be a central mystery in neuroscience and consciousness studies. Across the English Channel, a very different kind of universe, equally mechanistic yet radically different in its fundamental assumptions, was being imagined in the singular, profound mind of Isaac Newton. He began with a Stoic-like cosmos, a finite system of stars created by God within an infinite, mysterious, spiritual space, a cosmic stage set by the divine. But what Descartes had vehemently denied, the existence of atoms, the emptiness of the void, and the perplexing notion of forces acting at a distance across that void, Newton triumphantly affirmed as crucial elements of his grand cosmic architecture. His was a universe of absolute, undressed space, existing in its own right, independently of the matter it contained, a fixed, unchanging background against which all events unfolded. And across this vast, empty stage, the universal force of gravity acted instantaneously, an omnipresent, mysterious, invisible thread connecting every particle of matter to every other particle, reaching out across the void. It was a universe of discrete particles and universal forces, governed with breathtaking mathematical precision by his three elegant laws of motion, a system that explained the fall of an apple and the orbit of the moon with the same simple elegance. When the theologian Richard Bentley, in a series of thought-provoking letters, pointed out a crucial logical flaw in Newton's initial conception that a finite system of stars, held together by their mutual gravitational attraction, would inevitably over time collapse inwards to its center, forming a single, immense mass, Newton was profoundly jolted into rethinking his cosmology. To avoid this catastrophic cosmic collapse, this inevitable gravitational implosion, he reluctantly realized the universe must be infinite. He was thus forced to abandon his initial Stoic vision of a finite island of matter and embrace an infinite, Epicurean-like cosmos, endlessly populated with uniformly distributed stars, held in a delicate, perfectly poised, and inherently unstable balance by the pull and counterpull of an infinite gravity. Any slight deviation from perfect uniformity, any subtle imbalance in this infinite distribution of matter, he realized, would trigger a catastrophic, runaway collapse. This perfect, seemingly precarious balance, he argued, was not a mere accident, but irrefutable proof of a divine power that had not only framed the system with such exquisite precision, but continually maintained it, constantly adjusting it, preventing its inevitable descent into chaos or collapse. Yet, even as this magnificent Newtonian vision of an infinite, static, perfectly balanced universe took hold and became the dominant scientific paradigm, the naked eye and the ever-improving power of the telescope began to tell a subtly different, more nuanced story. The stars, it was becoming increasingly clear, were not uniformly distributed across the infinite void. The great, ghostly arch of the Milky Way, our own Via Lactea, stretching across the night sky, hinted at a grander, more localized structure, a distinct cosmic neighborhood. This led visionary thinkers like Thomas Wright in England, in his original theory or new hypothesis of the universe, 1750, and more famously and comprehensively, Immanuel Kant in Germany, in his Universal Natural History and Theory of the Heavens, 1755, to propose that our sun was not a solitary star but part of a vast lens-shaped disk of stars, a distinct stellar system. And Kant, with his profound philosophical imagination, took the idea a revolutionary step further, boldly imagining that the faint, fuzzy patches of light, the mysterious nebulae visible through telescopes, were in fact other such island universes, distant Milky Ways, colossal collections of stars, scattered through the infinite void, each one a galaxy in its own right. He even imagined a grand cosmic hierarchy, these star islands clustered into systems of islands, and those into even vaster systems, ad infinitum, creating an infinitely nested, fractal-like cosmos. William Herschel, the gifted musician turned preeminent observational astronomer, along with his equally talented sister Caroline, spent a lifetime meticulously charting the heavens, diligently sweeping the skies with immense, powerful reflecting telescopes of his own making, pushing the boundaries of observation. He observed countless nebulae, and for a time he was convinced he was seeing other Milky Ways, exclaiming with awe and excitement in a letter that he had discovered 1,500 universes. But there was a competing and equally compelling idea, the nebula hypothesis, most eloquently and mathematically developed by Pierre-Simon de Laplace. This hypothesis saw these fuzzy patches not as distant, mature galaxies, but as nearby, swirling clouds of primordial gas, nebulae, truly in the process of condensing and collapsing under their own gravity to form new stars and planetary systems, just like our own solar system was believed to have formed. The central, defining debate of 19th century cosmology became precisely this. Are we inhabitants of a one-island universe, a single grand, immense galaxy, in which new solar systems are continuously being born from local clouds of gas and dust? Or are we part of a many-island universe, a boundless cosmos filled with countless other galaxies, each a grand stellar system like our own scattered through the vastness? Herschel, in his later years, after observing many nebulae that looked more like a shining fluid than a collection of resolved stars, swayed toward the one-island view, believing that our galaxy was the sole universe. This one-island view, the concept of a single, magnificent galactic island, with our solar system comfortably situated, albeit mistakenly, near its providential center, serenely afloat in an infinite, mysterious void, became the standard Victorian universe. It was, in essence, an updated, grander-scale return to the old Stoic model, comfortingly familiar in its overall structure, a finite, ordered home within an infinite, indifferent expanse. And for over a century, this was the accepted cosmos, the framework within which scientific inquiry proceeded. But it was a cosmos under increasing temporal strain, a profound chronological tension. The immense timescales now demanded by the burgeoning fields of geology, with its evidence of deep time and slow processes, and Darwinian evolution, with its requirement for vast eons for life to diversify, clashed profoundly and irreconcilably with the estimated age of the Sun, calculated by the brilliant physicist Lord Kelvin. Based on the energy it could release through gravitational contraction, Kelvin estimated the Sun's age to be no more than a few tens of millions of years, a mere blink in geological time. This deep-seated conflict, this stark discrepancy between the age of the Earth and the age of the Sun, was a significant, lingering wound in the body of Victorian science, a persistent puzzle that threatened the coherence of scientific understanding. This wound was only truly healed at the very turn of the 20th century, with the revolutionary discovery of radioactivity by Henri Becquerel and the groundbreaking work of Pierre and Marie Curie. This new physics, exploring the very heart of the atom, revealed a vast, previously unknown source of immense energy locked within the atom itself, a power far beyond gravitational contraction. Not only did this elegantly explain the sun's astonishing longevity, providing an internal furnace that could burn for billions of years, but it also provided a powerful new cosmic clock, radioactive dating, which definitively confirmed that the Earth, and by extension the universe, were indeed billions of years old, not millions. The cosmos, it was now understood, was not only unimaginably vast in space, but also unimaginably ancient in time, a realm of deep history and slow, unfolding processes. And it was in these newly revealed, immense depths of space and time that the final, decisive act in the 2,000-year-long intellectual drama between the Stoic, one-island, and Epicurean, many-island, cosmological models was finally played out, reaching its ultimate resolution. In the early, vibrant decades of the 20th century, a period of immense scientific upheaval and groundbreaking discovery, the great debate that had simmered for centuries was finally and definitively settled. The young, brilliant American astronomer Harlow Shapley, through his meticulous and pioneering study of the distribution of ancient, compact globular star clusters that swarm like luminous bees around the halo of our galaxy, fundamentally overthrew the long-held idea that our sun was at or near the center of the Milky Way, a notion that had persisted since the time of Galileo. He found that these ancient luminous clusters formed a vast spherical halo, a majestic cosmic scaffolding, and their precise center, the true gravitational heart of our magnificent galaxy, lay tens of thousands of light-years away from our solar system, hidden from our direct view by vast, opaque dust clouds in the direction of the constellation Sagittarius. The old galactocentric theory, even in its updated form, was unequivocally dead. For a brief period, Shapley, emboldened by his discovery, defended an even grander, more expansive one-island model, proposing that our entire galaxy was a vast, solitary continent of stars, a singular universe unto itself. But it was Edwin Hubble, a meticulous and visionary American astronomer, observing the faint, spiral nebulae with the powerful new 100-inch telescope on Mount Wilson in California, then the largest telescope in the world, who delivered the final, decisive, and irrevocable blow to the one-island universe concept. Using a newly discovered and astonishingly reliable cosmic yardstick, a special type of pulsating star known as a Cepheid variable, whose period of pulsation is directly and precisely related to its intrinsic brightness, allowing astronomers to calculate its true luminosity and thus its distance. Hubble was able to measure the distances to these enigmatic nebulae. His painstaking measurements, meticulously recorded and analyzed, proved conclusively and irrevocably that these spiral nebulae were not nearby clouds of gas within our own galaxy, as the nebula hypothesis had proposed. Instead, they were immense, incredibly distant, island universes, great cities of stars in their own right, millions upon millions of light-years away, each a galaxy comparable in scale to our own Milky Way. The Epicurean many-island universe, a cosmos of countless galaxies, had triumphed at last. The long, silent competition was over. The cosmos, in this stunning new picture, was revealed to be a boundless ocean, a vast sea of darkness, filled with a countless archipelago of galaxies, each one a jewel box of stars. This, then, is our modern cosmic address. We live on a tiny, fragile planet, orbiting an ordinary yellow dwarf star, located not at the center of the cosmos or even our galaxy, but in the quiet, relatively serene suburbs of a vast, majestic spiral galaxy, our home, the Milky Way. This galaxy, our magnificent celestial city, is 100,000 light-years across, a swirling, dynamic disk composed of at least 100 billion stars, along with vast, ethereal clouds of gas and dust, the raw material for future star formation. This flat, rotating disk contains the young, chemically enriched stars of what astronomers call Population 1, vibrant, blue, luminous stars, born from the recycled ashes of previous stellar generations, enriched with heavier elements. Encircling this bustling, vibrant disk is a vast, diffuse, spherical halo, a ghostly realm of ancient, chemically primitive, Population 2 stars, many of which are bound together in compact, ancient globular clusters, tracing out long, slow, elliptical orbits like celestial spirits, remnants of an earlier age, remembering the primordial conditions of our galaxy's birth. We are undeniably a part of this cosmic city, this grand galactic home, but we are far from its bright, tumultuous, supermassive black hole-powered center. And beyond the immense, shimmering confines of our own galaxy, stretching away into the deep, dark abyss of intergalactic space, lie the others, an unimaginable multitude of them. They appear in two great overarching families: the majestic spirals, like our own Milky Way, and the magnificent Andromeda Galaxy, with their beautiful, pinwheeling arms, elegantly traced by the brilliant blue light of newborn massive stars and the glowing nebulae where they form, indicators of active star formation. And then there are the serene ellipticals, great spheroidal swarms of ancient redder stars, largely devoid of the gas and dust required to form new generations of stars, appearing as tranquil cosmic embers. And these galaxies, these luminous cities of stars, are not scattered randomly like dust motes dancing in a sunbeam. They congregate, drawn by the invisible hand of gravity, in immense clusters, sometimes hundreds or even thousands of galaxies bound together. And these clusters of galaxies are themselves grouped into colossal superclusters, vast aggregations of matter spanning hundreds of millions of light-years, which in turn form vast, interconnected filaments, and immense, sweeping great walls of galaxies, stretching across hundreds of millions of light-years, outlining a vast, intricate cosmic web. These luminous structures separate immense, dark, and startlingly empty cosmic voids, regions of almost complete emptiness, where galaxies are largely absent. This, then, is the universe as we now map it, a cosmic tapestry woven from luminous threads of matter and vast stretches of emptiness. But as we look out to chart this grand, intricate map, as our instruments reach further and further into the cosmic depths, we face a new and profound kind of boundary, a new definition of the edge that is woven not from tangible matter, not from crystalline spheres or walls of stars, but from the very fundamental fabric of reality itself, the inextricably intertwined nature of space and time. The theory of special relativity, born from the extraordinary revolutionary mind of Albert Einstein at the dawn of the 20th century, revealed a truth that shattered the Newtonian absolute, that space and time are not the separate, independent absolute stages, the inert backdrop that Newton had so confidently imagined. They are, instead, inextricably woven together into a single, seamless, four-dimensional continuum, spacetime. And in this unified spacetime, two fundamental principles hold true, universally, for all observers, no matter how they are moving, no matter their relative velocity. The first is that the speed of light in a vacuum is an absolute cosmic speed limit, a universal constant that remains precisely the same for everyone, regardless of the motion of the source or the observer. Nothing, no information, no matter, can travel faster than light. The second principle is that while measurements of distance in space and duration in time are relative, varying from one observer to another depending on their relative motion, a particular invariant combination of the two, the space-time interval, the distance between two events in space-time, is absolute and invariant for all observers. Your now, your slice of simultaneity is not my now. My meter stick, if observed from your moving frame, may appear shorter to you, and my clock may appear to run slower. But we will both, without question or ambiguity, agree on the absolute, unchanging space-time interval between any two events, regardless of our frames of reference. This profound and counterintuitive discovery led the mathematician Hermann Minkowski, one of Einstein's teachers, to famously declare in 1908, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." In this profound view, the universe simply is a fixed, eternal, four-dimensional tapestry of interwoven world lines, a block universe where every event, past, present, and future, exists together, simultaneously, frozen in a timeless whole. The perceived flow of time, the experience of moments passing, becomes a kind of persistent illusion, a trick of our consciousness, as it journeys along the world line of our own body, traversing this unchanging tapestry. This new, strange geometry of flat spacetime, as described by special relativity, describes a universe devoid of gravity, a hypothetical realm where masses do not interact. But gravity, as we know, is everywhere. It shapes galaxies, sculpts planets, and governs the very dance of the cosmos. This undeniable omnipresence of gravity led Einstein on a decade-long intellectual odyssey, a relentless pursuit of a deeper truth, culminating in his greatest and most beautiful creation, the theory of general relativity, published in 1915. The first crucial clue came from what he famously called his happiest thought of his life, the profound principle of equivalence. This states that the effects of gravity are completely and fundamentally indistinguishable from the effects of acceleration. Imagine an astronaut sealed inside a windowless spaceship. If that spaceship is accelerating uniformly through empty space, far from any gravitational source, the astronaut would feel a constant force pinning them to the floor, identical in every way to the sensation of gravity. Conversely, an astronaut in a free-falling elevator or in orbit around the Earth, experiencing continuous freefall, would be weightless, floating freely. The inertial force of their accelerated motion through space perfectly cancels the gravitational pull. This startling insight led Einstein to a revolutionary, almost poetic, conclusion. Perhaps gravity is not a mysterious force acting across empty space at all. Perhaps instead, it is a manifestation of the geometry, the subtle curvature of space-time itself. Matter and energy, he proposed, do not simply move through a passive, flat space-time that acts as an inert stage, an unchanging backdrop for cosmic events. Instead, they actively tell space-time how to curve, how to warp, how to bend, and in turn, the resulting curvature of space-time tells them how to move, dictating their paths. What we conventionally call a gravitational field is simply the shape of space-time, its intricate geometry, warped and bent by the presence of mass and energy within it. Planets orbiting the Sun are not being pulled by a mysterious, invisible force acting across empty space, reaching out and tugging them. No, they are simply following the straightest possible path, a path known as a geodesic, through the curved spacetime that the Sun's immense mass has created around itself. The Earth orbits the Sun for the very same fundamental reason that a marble circles the inside of a funnel, following the contours of its curved surface. It is simply following the geometry of the space it inhabits, a path that appears curved to us, but is, to the planet itself, the straightest possible trajectory through its warped cosmic environment. This new radical vision of gravity, no longer as a force but as the dynamic curvature of the very fabric of reality, changes absolutely everything. It means, for instance, that gravity propagates not instantaneously across vast distances, as Newton's theory implied, but at the finite speed of light, as ripples in spacetime itself, disturbances known as gravitational waves, elusive cosmic tremors that we are only now, in the second decade of the 21st century, beginning to detect with exquisite instruments, opening a new window onto the universe. It means that even massless light, which travels along these geodesics, must be bent by gravity, its path subtly curved as it follows the contours of warped spacetime. During a total solar eclipse in 1919, an expedition led by the British astronomer Arthur Eddington observed that the apparent positions of stars seen near the darkened limb of the Sun were slightly displaced from their usual positions. The Sun's immense gravity was indeed bending their light, and, by precisely the amount that Einstein's theory predicted, a stunning confirmation that catapulted Einstein to global fame, this new theory of gravity also elegantly explained a tiny, lingering anomaly in the orbit of the planet Mercury, a slow, gradual precession or shift of its elliptical path around the Sun, that Newtonian gravity, despite its remarkable accuracy for most phenomena, could not fully account for. The very fabric of spacetime around the Sun is being subtly twisted by the Sun's rotation, a phenomenon known as frame dragging, gently tugging and dragging Mercury's orbit along with it. And most profoundly, general relativity predicts that time itself runs more slowly in stronger gravitational fields, a concept known as gravitational time dilation. A clock at sea level, deep within Earth's gravitational well, will tick ever so slightly slower than an identical clock placed on a mountaintop, where gravity is marginally weaker. This is not a mechanical defect in the clock. It is a fundamental, verifiable property of time itself, woven into the very structure of spacetime. It means that light, as it climbs out of a gravitational field, must lose energy, its waves stretching to longer, redder wavelengths in a process called gravitational redshift. All of these strange and beautiful predictions, once seemingly fantastical and utterly counterintuitive, have been verified with astonishing and ever-increasing precision through numerous experiments and observations, from atomic clocks on airplanes to signals from distant pulsars. They tell us, unequivocally, that the stage of our cosmic drama is not passive and unchanging. It is an active, dynamic, curving and warping participant in the cosmic dance, bending and shaping the paths of everything within it. General relativity's most extreme and perhaps most mind-bending prediction, however, is the existence of a place where spacetime is so severely curved, so profoundly distorted, that it effectively tears itself from the rest of the universe, creating a region from which nothing, not even light, can escape. This is the black hole, a cosmic enigma, a profound boundary. When a very massive star, perhaps many times the mass of our Sun, exhausts its nuclear fuel, The outward pressure from its internal fusion reactions, which had previously counteracted the inward pull of gravity, ceases. Its own immense gravitational force then triggers a catastrophic, inexorable collapse. If the star is massive enough, beyond a certain critical mass known as the Chandrasekhar limit for white dwarfs or the Tolman-Oppenheimer-Volkoff limit for neutron stars, no known force in nature, not even the degenerate pressure of quantum mechanics, can halt this implosion. Gravity overwhelms all opposition, crushing matter beyond imagination, and the star continues to collapse, relentlessly compressing itself down to an infinitely dense and infinitesimally small point, a singularity, a point where spacetime curvature becomes infinite and the laws of physics, as we currently understand them, break down. To an observer watching this cosmic drama unfold from a safe, distant location, this collapse appears as a strange and incredibly slow affair, warped by the extreme gravity. As the star shrinks inward toward a critical size, known as the Schwarzschild radius, which for a star with the mass of our Sun would be about 3 kilometers, smaller than a typical city, the gravitational redshift from its surface approaches infinity. Light escaping from its increasingly strong gravitational pull becomes progressively redder and dimmer, its photons struggling against the pull, losing energy until they are no longer visible. Time on the star's surface appears to slow down, grinding to a complete and utter halt as it reaches this critical radius, the star appearing frozen, eternally suspended. The star appears as a dark, ghostly shadow against the cosmos, a timeless silhouette from which nothing, not even light, can ever escape. This profound boundary is the event horizon, a one-way membrane in space-time. It is the ultimate edge, not a physical surface you could touch or stand upon, but a boundary in the geometry of space-time, the absolute point of no return. Once you cross this threshold, you are committed. Inside the event horizon, the curvature of space-time becomes so extreme, so overwhelming, that all possible paths, all future-directed world lines, all trajectories through space and time lead inevitably to the central singularity. For an observer falling across this boundary, a strange and utterly profound transformation would occur. Space and time effectively exchange their roles. The radial direction, moving inexorably towards the center of the black hole, becomes the inevitable direction of the future, just as for us, time always moves forward. Trying to move outward, away from the singularity, would be as impossible, as physically futile, as trying to travel back into the past. One must fall inexorably toward the future, and the future is the crushing singularity. In this bizarre region, space itself is flowing into the black hole like a cosmic river, and at the event horizon, this river of space flows inward at the speed of light. To escape, one would have to travel through this flowing space faster than light itself, which, as we know, is impossible. You would be swept to your doom, your existence destined for the singularity. And yet, remarkably, astonishingly, this isn't the final word on this cosmic edge, this profound boundary of black holes. When the subtle probabilistic laws of quantum mechanics, governing the behavior of matter and energy at the smallest scales, are taken into account, as the brilliant theoretical physicist Stephen Hawking demonstrated with breathtaking insight in the 1970s, black holes are not perfectly black, not truly eternal prisons of darkness. The vacuum of empty space, in the quantum view, is not truly empty, not a passive void. It is, paradoxically, a seething, effervescent froth of virtual particle-antiparticle pairs, electrons and positrons, quarks and antiquarks, that continuously pop into and out of existence for fleeting moments, borrowing their existence from the inherent uncertainty principle of the quantum void itself. Near an event horizon, where gravity's tidal forces are incredibly intense, These forces can wrench a virtual pair apart before they can annihilate each other. One particle, perhaps the negative energy particle, might fall into the black hole, effectively reducing its mass, while its positive energy partner escapes into the universe, carrying away energy. To a distant observer, it appears as if the black hole itself is spontaneously emitting radiation, a faint but steady glow. This phenomenon is known as Hawking radiation. This radiation has a perfectly thermal spectrum, just like a hot object, meaning the black hole has a measurable temperature. And stranger still, the smaller the black hole, the hotter it is, and the more rapidly it radiates, converting its mass into energy. Over truly immense, almost inconceivable spans of time, black holes slowly, patiently evaporate, radiating away their mass and energy back into the universe, a process that takes an eternity for large black holes. A solar mass black hole, for instance, would take a Google years, a 1 followed by 100 zeros, to completely disappear. But a microscopic black hole, perhaps forged in the searing heat and extreme pressures of the Big Bang, and having the mass of a mountain compressed into the unimaginable size of a proton, would erupt in its final moments in a brilliant, violent flash of high-energy radiation, a miniature cosmic explosion. This astonishing discovery resolved a profound paradox that had long plagued physicists. Black holes seem to destroy information about what fell into them, violating a fundamental principle of physics known as the conservation of information. But if they have a temperature, they must also have entropy, which is a measure of their hidden, inaccessible information. Hawking showed that a black hole's entropy is precisely proportional to the surface area of its event horizon. Black holes, then, are not eternal prisons for information. They are cosmic slow cookers, eventually returning their contents, albeit in a scrambled and thermalized form, to the universe in the form of a slow, steady simmer of thermal radiation. They are, in a strange and beautiful sense, the most perfectly ordered objects in the universe, characterized by their immense entropy. So we find that our profound journey to the edge of space has led us, not to a single, monolithic boundary, but to a multiplicity of edges, of horizons, each one revealing a deeper layer of cosmic truth. We have explored the event horizon of a black hole, an absolute, one-way boundary in spacetime, a point of no return, and we have the horizons of our expanding universe itself, boundaries that are not static walls, but dynamic, ever-receding frontiers of light and knowledge. As we sit here quietly contemplating these cosmic vastnesses from our small planet, we are, in a very real sense, at the center of our very own Hubble sphere, a vast, observable region of space roughly 15 billion light-years in radius. Beyond this invisible boundary, all galaxies are observed to recede from us at speeds faster than the speed of light. This is not, it must be emphasized, a violation of Einstein's special relativity. The galaxies themselves are not moving through space at these impossible speeds. Rather, the vast expanse of space between us and them is being actively created, stretching and expanding so rapidly that the distance between us grows at a superluminal rate, carrying those distant galaxies away faster than their light can reach us. Light emitted from those distant galaxies in our direction is swept away from us, like a tireless swimmer struggling against a cosmic current that is simply too strong to overcome. This dynamic boundary, the Hubble sphere, is our photon horizon, the place where the river of expanding space flows away from us at precisely the speed of light, carrying light with it. But there is another, even deeper horizon, that truly defines our ultimate edge of visibility, the ultimate limit of our direct observation. Because the universe has a finite age, approximately 13.8 billion years since the Big Bang, there is a finite distance that light can possibly have traveled since the very beginning of time, since the first flicker of existence. This boundary is the particle horizon, the true edge of our observable universe, the sphere that encompasses all matter and energy from which light has had time to reach us. We can see absolutely nothing beyond it, for the simple, insurmountable reason that the light from those more distant regions has not yet had sufficient time to traverse the vast, expanding cosmos and reach our telescopes. Every moment that passes, every second that ticks by, this horizon subtly recedes, revealing a little bit more of the grand cosmic tapestry to our view, like a curtain slowly drawing back to reveal a stage. Yet, the very existence of this particle horizon and what we observe within it presents a profound and persistent puzzle, the horizon problem, one of the great cosmological mysteries. When we look out at the cosmic microwave background radiation, that ancient fossilized light, the faint, uniform afterglow of the Big Bang, we see that it is astonishingly uniform in temperature across the entire sky, no matter where we look. The temperatures of regions seen in opposite directions of the sky are precisely the same, to within 1 part in 100,000, an incredible degree of thermal equilibrium. But at the time this ancient radiation was emitted, when the universe was only a few 100,000 years old, before stars and galaxies had even formed, these two now opposite regions of the sky were separated by nearly 100 times their own horizon distances. They could not possibly have been in any form of causal contact. Light, the fastest messenger, simply did not have enough time to travel between them. They should have had no way of knowing about each other's existence, no way of exchanging heat or information. So how did they come to have the exact same temperature, to be in such perfect thermal equilibrium? It is as if two people who had never met, had no shared history, no common language, and were raised on opposite sides of an uncrossable chasm, spontaneously began to recite the exact same epic poem, word for word, at precisely the same rhythm, a feat of impossible synchronicity. This deep mystery, along with another equally profound cosmological puzzle called the flatness problem, the perplexing question of why our universe seems to have a geometry so precisely balanced on the razor's edge between being eternally open and expanding forever, and eventually collapsing back upon itself in a fiery big crunch, led cosmologists to a revolutionary and still debated idea: cosmic inflation. Perhaps, in the first fleeting fraction of a second of its existence, an infinitesimally brief period of time almost immeasurably small, the universe underwent a period of extraordinarily rapid accelerated expansion, growing at an exponential rate. A kind of cosmic tension, a negative pressure inherent in the primordial vacuum of space itself, a temporary repulsive gravitational force, may have caused a tiny subatomic patch of the very early universe, a region already small enough to be in perfect causal contact and thermal equilibrium, to inflate by an unimaginable factor, at least 10 to the power of 50 times in a fleeting instant. This exponential stretching would have flawlessly flattened any initial curvature, any inherent warp or twist in spacetime, just as rapidly inflating a crumpled, wrinkled balloon to an immense size smooths out all its tiny wrinkles until its surface appears perfectly flat and uniform. And it would have taken that single tiny, uniform, causally connected patch and stretched it to become vastly astronomically larger than our entire observable universe today. In this elegant picture, the universe we observe, the one we can see with our telescopes, is so astonishingly uniform, so remarkably flat, and so isotropic, looking the same in all directions, precisely because we are merely living in just one microscopic, causally connected corner of a single, immense, smoothly inflated region, a tiny bubble within a much larger, unseen cosmos. Inflation elegantly provides a natural and compelling solution to why our cosmic home is so vast, so flat, and so isotropic. It also provides a natural solution to another enduring puzzle: exotic, super-heavy magnetic monopoles. Isolated magnetic poles, unlike the north and south poles always found together in ordinary magnets, are predicted by our best theories of fundamental physics to have been created in great abundance in the searing heat of the very early universe. Yet we see none. Inflation elegantly explains their absence. The exponential expansion simply diluted their density to virtually zero, sweeping them so far apart that they are now beyond our observable horizon. Our universe inflated, and in doing so, it effectively swept the exotic, unwanted debris of its earliest, most energetic moments far beyond our most distant horizon, making them undetectable. Inflation paints a grand, compelling, and aesthetically pleasing picture of the universe's earliest moments, a powerful explanatory framework for many cosmic mysteries. But it inevitably leaves us with another deep, persistent puzzle, one that leads us to question the very composition of our reality. To achieve this state of near-perfect flatness, a key prediction of the inflationary model is that the total density of all mass and energy in the universe must be precisely equal to a specific value, the critical density, the exact amount required to one day halt its expansion if it were destined to collapse, or allow it to expand forever if it were open. Yet, when we meticulously add up all the luminous matter we can see, all the brilliant stars that twinkle in the night sky, all the glorious galaxies that populate the cosmic web, all the glowing gas clouds, everything that emits or reflects light, it accounts for only about 1% of this required critical density, a shockingly small fraction. Even when we generously include all the ordinary or baryonic dark matter, the matter made of protons and neutrons, whose existence we can infer from the primordial abundance of light elements like hydrogen and helium, and from the subtle gravitational effects on the motions within galaxies and clusters, things like cold, dark gas clouds, faint brown dwarfs, and the ghostly stellar remnants like stellar mass black holes, we still only reach about 10 to 20% of the critical density. This leaves a vast yawning gap, a profound deficit in our cosmic accounting. If the theory of inflation is indeed correct, and the universe is truly flat, then 80 to 90% of our universe is made of something we cannot see, something that does not interact with light, and something we do not currently understand: exotic, non-baryonic dark matter. The missing matter, whose gravitational pull is essential to hold galaxies and clusters together. The ongoing, relentless quest to identify this mysterious substance, perhaps in the form of weakly interacting massive particles, or WIMPs, particles that interact only through gravity and the weak nuclear force, is one of the greatest challenges and most exciting frontiers in modern science, requiring vast underground detectors searching for elusive interactions. If it is true, it means that the shining stars and glorious galaxies, the luminous structures we cherish and admire, are merely the delicate shimmering foam on a deep, dark, and utterly invisible cosmic ocean of matter, an unseen entity that truly governs the ultimate gravitational fate of our cosmos, shaping its large-scale structure. And what, finally, is that ultimate fate? What lies at the final, distant edge of time itself, the ultimate horizon of cosmic existence? Our destiny, the universe's long-term future, appears to be written, subtly yet definitively, in the precise total density of the universe, and, more mysteriously, in the enigmatic nature of an even stranger component that has only recently revealed itself: dark energy. This pervasive, enigmatic force is a modern incarnation of Einstein's cosmological constant, a faint but pervasive energy of the vacuum itself, an intrinsic property of empty space that seems to be causing the expansion of the universe to accelerate once again, pushing galaxies apart with increasing speed, defying the expectations of gravity. If, against the powerful predictions of inflation and our current observations, the universe is closed, with a total density of matter and energy greater than the critical value, then gravity will eventually triumph over expansion. Billions, or perhaps hundreds of billions of years from now, the expansion will inexorably slow, halt, and then reverse. The great cosmic river, which has flowed outwards for so long, will change its direction of flow, pulling everything inwards. The galaxies will fall back towards one another, their ancient light becoming intensely blue-shifted as they rush together, the sky growing hotter and brighter, ever more compressed with each passing millennium. Eventually, stars and galaxies will merge in fiery collisions. Matter will be torn apart into its constituent fundamental particles by the rising tide of heat and density, and the universe will end in a final fiery collapse. A big crunch, a violent and singular finale, perhaps imploding into a new singularity. This singular end might, perhaps, become the seed of a new Big Bang in an oscillating, eternal cycle of cosmic creation and destruction, a universe that breathes in and out through infinite eons. But if the universe is open, density less than critical, or flat, density exactly critical, as the theory of inflation and our current, increasingly precise observations of the cosmic microwave background and distant supernovae increasingly suggest, it will expand forever, a future of endless dispersal. The future, then, will be one of ever-increasing cold and loneliness and profound darkness. Over hundreds of billions of years, the stars will exhaust their nuclear fuel, their internal fires flickering out, leaving a universe populated by stellar corpses, cold, dense white dwarfs, rapidly spinning neutron stars, and enigmatic black holes. Over trillions upon trillions of years, the orbits of these dead stars within their dark, silent galaxies will slowly decay, and most will spiral into the supermassive black holes at the galactic centers, increasing their mass. Over googles of years, timescales so vast that they defy human comprehension, even these massive black holes themselves will slowly, patiently, evaporate through the ghostly, quantum process of Hawking radiation, radiating away their mass until they are gone. And on even longer, truly unimaginable timescales, beyond quadrillions, beyond quintillions of years, it is even possible that the protons themselves, the very building blocks of matter, may decay, dissolving the very last remnants of matter into a thin, cold, dispersed mist of fleeting radiation. The universe, our magnificent cosmic home, will end not with a dramatic, fiery bang, but a long, slow, and profoundly quiet whimper, fading into an endless night of near-perfect, empty silence, a final cosmic peace. We began our profound journey by asking about the elusive edge of space, seeking to understand the limits of our cosmic dwelling. And through this long, winding exploration, we have found that our universe is bordered not by a tangible wall of crystal, not by a flaming rampart of fixed stars, but by intricate, dynamic horizons of light, of time, and ultimately, of knowledge itself. These are not physical barriers, but conceptual boundaries, defined by the laws of physics and the finite speed of light. And now, as our own consciousness, that flickering spark of awareness, prepares to cross its own nightly horizon, drifting into the tranquil realms of slumber, we face the final, most intimate boundary of all, the one that exists between the universe that we can so meticulously model and precisely measure, the objective reality out there, and the subjective consciousness that performs the modeling and the measuring, the inner world of thought and experience. Where, we might ask, in any universe, is the cosmologist who studies that very universe? Our intricate physical models, our grand theories, can certainly contain our bodies and our brains, describing the intricate, beautiful dance of neurons and atoms, the electrochemical ballet that gives rise to thought. But can they truly contain the mind that conceives of them, the consciousness that experiences them, the awareness that dares to ask such questions? Can an image ever truly contain the image maker, the painter within the painting, the dreamer within the dream? Or are we, the conscious observers, the ones who perceive and ponder, forever subtly outside the picture we paint, an intrinsic part of the true, unplumbable universe, the ultimate, unknowable reality that is perhaps dreaming these physical universes into existence, constantly unfolding in its boundless mystery? Perhaps life, this precious, fragile phenomenon, is not just an accidental passenger in the immense, indifferent vastness of the cosmos, a mere chemical anomaly. Perhaps it is, instead, an essential, intrinsic participant, a fundamental part of the cosmic unfolding. In this cosmos so exquisitely fine-tuned for our very existence, where the fundamental constants of nature seem perfectly balanced to allow for the emergence of complexity, where intelligent beings can evolve to look up at the ancient, silent stars and question their own origins, their own destiny, we find ourselves to be far more than just insignificant inhabitants of a remote, ordinary world. We are, perhaps, the universe's way of knowing itself, its silent gaze turned inward, its reflection shimmering in the depths of our own minds. The stars shine, the galaxies spin, the universe expands, and through our eyes, through our minds, through this fragile flicker of human consciousness, this vast, silent cosmos awakens to itself, becomes aware of its own magnificent existence. This vast, silent, and intricate dome of many-colored glass, our cosmic tapestry, is, in this precise moment, stained with the white radiance of a single astonishing thought, a profound realization that echoes through the deepest chambers of our being. I am. And in that simple, profound realization, in that fragile, precious flicker of self-awareness against the backdrop of an unimaginable